Okay, so I think I'm going to get going with just a quick introduction to Phenix. I'm going to guess that a lot of you have used Phenix before, which is great. But for those of you that haven't or haven't for a while, I thought it'd be good to do a quick introduction and then a very quick tour of the graphical interface. Those of you that have Phenix installed should be able to follow along with some of the things in the session. You don't have to, but if you can and you want to, you should. And that might prompt you to ask some questions. Unfortunately, if you're having problems running Phenix, because the way something's set up on your computer, we can't really debug that live right now, unfortunately. But if you do encounter problems, you can send an email to the help at Phenix and we'll try and sort things out for you later on. Okay. So, quick introduction. And just to point out that Phenix is a collaboration between several groups. It's a really great project to work on because we get to work with each other. So my group here in Berkeley, Randy Reed's group in Cambridge, and you'll hear from Randy and colleagues this morning. Tom and Li Wei in Los Alamos, New Mexico Consortium, and then Matt Baker and Corey at Baylor College of Medicine, who work on some model building tools for cryo-EM, and then Jane and Dave's group at Duke, and you'll hear from Christopher tomorrow on validation. And just a quick reminder, if you've not seen it, there was a new paper we published last year which talked about all the recent developments in Phenix for crystallography and cryo-EM. And so if you use Phenix, you should cite that paper. So we started developing Phenix 20 years ago now, and that seems like a very long time ago. And we started off trying to develop Phenix as a new platform for crystallography, actually, really, and that's the topic of today and tomorrow. And it's built on top of an open source library. It's got a lot of tools for doing crystallography and other things. But over the years, it's developed into a larger thing with a lot of collaborations with other people and a lot of tools, including things like cryo-EM, but interactions with a lot of different software packages, including things like Rosetta, MD force fields with Amber, neutrons. So the scope of the project's a lot larger than just crystallography now. And so we developed Phenix with the idea that we wanted it to automate structure solution a bit more. 20 years ago, there was this thing that was sort of starting called structural genomics as an idea, try and solve a lot more structures. And it was going to be hard to do that if everything was very manual. So we wanted to automate things more and use modern programming tools to make something that's usable for people who are new to crystallography, but also people who are very experienced and have sort of hard problems to solve. And something we could develop. You might wonder why it's called Phenix. It's called Phenix because it's based around a scripting language called Python. 20 years ago, most people didn't know what Python was. I think now everybody does because it's used a lot. It's used a lot for things in the context of machine learning. A lot of tech software that's developed is based around Python these days. So some of the key features of Phenix is we use Python to make it easy to write Phenix for the developers. And we've implemented a lot of crystallographic algorithms, and we'll hear about a lot of these actually the next day or two. And also because of Python, it means that we can fix things quite quickly. So you should be able to get hold of bug fixes in a few days, not waiting months. And so this is the process of crystallography. It doesn't always work so smoothly as I'm showing it here, but these are the steps that we have to go through. You know, solving the phase problem, building a model, refining the model, ligands, things like that, and deposition. As I said, we'll talk about a lot of these things today and tomorrow. But just to point out that there are tools in Phenix to try and deal with all of these things, all of these different things that we have to do in crystallography. A lot of those tools are more automated, whereas some are less automated. A lot of the things like phasing, as you'll hear today, there's a lot of automation there. There's a lot of automation in building models, a lot of automation in molecular replacement, actually. But things like refinement are not so easy to automate, and you have to think a lot. You have to think a lot all the way through this, of course, but refinement is a place where there's a lot of thought that needs to go into doing that. So there are different ways you can use Phenix. One way is from the command line. Some of you may be familiar with that on your computer. You can open up a terminal window and type things, right? So that's one way to use the Phenix programs. It's just some examples here. And there's a lot of automation going on here potentially as well, right? There's a program where you give it a data file and a sequence, and it goes off and solves the structure in large part. So that's a very reasonable way to use Phenix. I think a lot of people, myself included, tend to use the graphical interface because it's a nice way to interact with software. You've got a lot of information here, and we'll quickly look at this interface after I finish talking, just so everybody's familiar with it. And that's what we're going to use for the majority of what we're talking about today and tomorrow. Another thing that we did early on in Phenix was to integrate it with Qt, model building program, which I imagine many of you are familiar with, and also PyMol, which is a visualization program. So I'm sure everybody has heard a lot about cryo-electron microscopy and how it's developed very quickly over the last few years and become a very, very important tool in structural biology. And you might get the impression that there's nothing left to do, or things aren't being developed in crystallography, but that's not true. And this I'm not going to go through all of these things, but this highlights a few of the things that we've done over the last few years in the area of crystallography in terms of development of new things, and those things continue. So there's always new developments to try and make crystallography better, because even though it's very mature, there are still things that aren't so straightforward. And as I said, things like refinement are not automatic by any means. So there's still a lot left to do. And some of you may be familiar with low resolution structure solution and how challenging that can be, and refinement of low resolution models. This is a problem in crystallography and cryo-EM. Some of you may also have higher resolution data and found that completing a structure takes a lot of time. Solving the structure might be done very quickly, but actually dealing with all the details, especially when you've got high resolution data, is a lot of work. And that's not very automatic right now. As I said, refinement has a lot of decisions that need to be made by you as a scientist. It's a complex problem. And there are things that make our life tricky, things like twinning, other pathologies in data that make life a little bit more difficult. And ultimately, crystallography is about chemistry at the end of the day. When you look at a protein structure, you're really looking at chemistry. And that's especially true if you're looking at maybe how a small molecule interacts with a protein or another macromolecule. And we can't fully automate that, certainly currently. So this is one of the things that I would recommend anybody doing crystallography learn more about is chemistry, because that will ultimately help make your life easier. I'll skip over this, but just to say that crystallography and cryo-EM actually have a lot of steps in common when you get past getting the initial sort of data or the reconstruction. So that's one of the reasons it's been possible to generate a whole set of tools, new tools for cryo-EM. Not the topic of this workshop, but it will come up in a future workshop. We'll do another cryo-EM workshop, I'm sure. So if you're interested in that, watch out for the announcement about that workshop. Okay, so hopefully you all know this, because hopefully you were able to install Phenix, but there's a website where you can go and download Phenix. It's supported on the platforms you're likely to be using. And there's a lot of documentation up at the top here. There is a link to documentation, and we recommend certainly looking at that to try and see if the documentation helps solve a question you have, or helps you understand what you're doing or what you could be doing. But if it doesn't, then there are places to email us, report bugs. There's a mailing list. So a lot of options to try and get help either from the community or from the developers. And we do build a new version of Phenix every day automatically. And if that version looks good, we will put it on the web. So these are what's called the nightly builds. And that's a great way to get access to the latest features, or if we told you we fixed a bug, if you told us you had a problem and we said we fixed a bug, we'll let you know that it's going to be out in a nightly build, and you can download that and install it. So it's great that you're all participating in this workshop, but there are other ways to get information about the tools in Phenix, and one of those is this YouTube channel, the Phenix Tutorials YouTube channel, where there are a lot of videos, short videos, about 5 minutes, that tell you about all sorts of things in Phenix. Not everything, but a lot of things. And this is a great place to start, or to remind yourself about the basics. If you've forgotten or not done something for a while, check out the videos to see if that reminds you about things. It may be a place that makes you think of some questions which you'd like to ask us. And so this is something that Dorothy and others have put a lot of work in putting together. So I'll wrap up just by saying thank you to all of the people that work on Phenix. I mentioned the folks on the left here at the beginning, but a lot of collaborations with other people. That's been one of the great things about the Phenix project over the years, is collaborations with lots of people, actually, more probably than included on this slide. And also thanks to you, the users, for using it and giving us feedback. It really helps us make the software better. And I should thank the NIH, who's been funding Phenix for the last 20 years, and also our industrial consortium, so industry that helps support the development of Phenix. And just a reminder about that new publication that describes Phenix. Okay, so I'm going to stop there. Great, and Claudia just put the link to the YouTube channel in the chat, if you want to check that out. So every so often somebody might drop something in the chat to check out. What I'm going to do now is start up Phenix. So if you have, on the paper as well, great, thanks. If you have questions, anything about what I've just said, feel free to drop it in the chat. As you're doing that, what I'm going to do is just very quickly, for those of you that are not familiar with the Phenix interface here, just quickly describe it. And you saw how on the Mac I was able to start this just by clicking on an icon. You should be able to do that on Windows as well. I think on Linux you may have to open a terminal and type Phenix to get it started. But this is the graphical interface. On the left, there is a list of the projects you worked on. So things are set up so that whenever you do something in Phenix, you're going to have a project associated with it. This is so that you can help manage where things are, not just have stuff randomly on your computer, but put in places that you can find them later on. So this is, and you can see I've got a very long list of projects, but if you've not used Phenix before, you may have nothing or one, something like that. Now you'll see there's a tab up here. The default here is projects, and you can start a new project by clicking the new project button. There is this job history that for a particular project, it tells you about the things that you've run. So a list of the various jobs that you've run, and you can see when you ran them, what they were called. If there was something interesting, then like the R factor, free R factor, then we're gonna show you that there. I can't make this full screen. The GUI is this size. I can do that, but it doesn't make the text any bigger. That's just the the way the graphical system works for the GUI. And do you need CCP4 to install Phenix on Windows? No, you don't need CCP4. You can just install Phenix. Great to install CCP4. It's a wonderful program too, set of programs, but you don't need to do that, no. So in the job history, you can delete jobs and things like that. You can click on a job and open it up and see what happened, what the input parameters and what the outputs were. On the right here, clicking on one of these little bars will give you a list of programs. So these, as you can see, are sort of laid out, sort of the way you go through crystallography, data analysis, phasing, micro replacement, maybe model building, refinement, validation, things like that. So hopefully that helps you navigate through the different things you might want to do. Right, Tom's just saying that in the view options, you can make my screen bigger in Zoom. So, and we'll see some of these things soon. So if we click on, probably do this with Tom shortly, click on AutoSol, it will open up the AutoSol window. So this is a job that we can now run. We set up the parameters and run it and things would happen. And then it would appear in our list of jobs in the history. At the top, there are a few helpful things, we hope. There's some preferences here. Don't necessarily have to change things in the preferences, but it may be necessary to, if Qt, for example, or PyMol are installed in an unusual place on your computer, you can set that location in the preferences so Phenix can find those programs. Normally it's automatic, but sometimes, say, it can be installed in odd places. There is a help button here, and that will open up either this kind of window here, or on some platforms it will open up a web browser. But this will give you the documentation for that version of Phenix that I just opened. And so, yes, somebody's just asking if we support the new Mac OS. Yes, we think it all works. It only just came out, but Billy tested it and it seems to be okay. So there is some overview documentation here. So just to orient you, we have that sort of flowchart of crystallography I showed you in my slides. You can click on one of these boxes and get information about what that part of crystallography is about and the programs that you might want to use in Phenix for that. Same thing for cryo-EM. We can click on things and see information about particular tasks. So that's a great way to navigate the documentation. There are links, if you don't want to click on a box, there are links, just text here. But there is also, just so you know, there is a complete Phenix reference documentation here. And if you click on that, you're going to get documentation about essentially every program, everything there is in Phenix. So that's a great place to drill down to some details if you want to get details about things. And there are a variety of other things that it's worth checking out here about how to install, tutorials, things like that. I'm going to close that. Over here, there are links to a direct link to Qt, PyMol, for example. King is a program from the Richardsons that helps you look at validation information. There is this other tools button here that just has a list of short little programs we didn't put in the main GUI because they're very short, but they can be pretty useful. You can, if you have an ID from a PDB ID from a paper, you can go and get that data from the PDB by clicking on this link. You can do some conversions of things. You can search the PDB if you've collected some data and you want to check that particular symmetry and unit cell hasn't been seen before because maybe you crystallized the wrong thing. That's a great thing to do there. So there's a whole bunch of little programs that you might find pretty useful. And then finally, this Ask for Help button is just a way to send us an email. It will send an email to the developers. So if you've got a question or a problem or something you're just interested in, feel free to put your email address in, otherwise we can't get back to you. But some extra information here, and shoot us an email. You'll also see the same window if the GUI encounters a bug or a problem when it's running. It will pop up this window, and it's great if you can send off the email to us because it helps us debug things. Okay, so hopefully that's just a quick review of the interface for those of you that aren't familiar with it. And I'm going to stop talking and stop sharing my screen as well, so that we can move on to Tom. Just quickly, though, go through some of the things that have appeared in the chat here. Some questions about whether we'll support Apple Silicon, the new computers that they just announced that aren't using Intel chips. They're using their own custom chips, the ARM chips. So yes, we do plan to do that. Things should run with their emulation initially, but we do want to get into building things that are native. We just need to get hold of a machine and figure that out. Somebody's asking about data processing programs. Well, we do actually distribute dials, as Billy said. We don't have a GUI with that right now, so it can be run from the command line, but we do want to have some interface to dials in Phenix in the future. Randy's just reiterating, yeah, if you report a bug, please make sure you've given us your proper email address. Otherwise, we can't get back to you, and you can actually set that up in the preferences so you can make sure that it's right. Yeah, and Billy's just saying that we ship dials 2.2 as part of Phenix currently.